In this question, an object has a kinetic energy of 200. A constant force of 190 Newton is applied on the object, and the distance moved is 10 meter. What is the final kinetic energy? So how we can work out the total kinetic energy, as we can in the question, an object has already having a kinetic energy of 200. So there is a Ke of 200 joules. Then a force of, like there's a work done, because whenever force is applied, so that the force is applied, which is 190, and the distance the object move, that is equals to 10 meter. So how much the work is done? The work done is force into distance, so it is 190 plus 10, so it will be 1900 joules. So 1900 joules is there. It's an extra thing or extra work which is done. So force of originally it was having a kinetic energy of 200, and then we did an extra work by applying a force of 190 and moved to 10 meters. So how much work we did? We did a work done of 1900. That extra 1900 is also added to that. So what will be the total will be there? So it will be 1900 plus 200. So it will be 2100 joules. Because whenever a work is done on the object, the work done is equals to the kinetic energy. So how much work is done? That is force multiplied by distance. So force was 190 and the distance is 10, makes it 1900. So 1900 joule is already, object was having 200 joules, and then extra 1900 joules is provided. So what will be the total energy? It will be 1900 plus 200, which is 2100 joules. Is it clear? This one? A sound wave produces 3000 crests every minute. So this is 3000 crests are there per minute, but it should be, because the frequency is how many waves are there in 1 second. So how many waves are in one, if there are 3000 in minute, so we have to divide it by 60 to know the frequency. Because what is the frequency? Frequency is how many waves or number of the vibrations are there per second. The time should be in second, but here the time is in minutes, so we convert the time into second. That's why 1 minute is equals to 60 seconds. So 3000, so 3000 divided by 60, that is equals to 50. So the frequency is 50 hertz. Now we need the wavelength, so v equals f lambda. V is the speed, which is 300, frequency is 50, and the wavelength we don't know. 50 is multiplied, other side it will be divided. So 300 divided by 50 is the wavelength, which is equals to 6 meters. So first, because this was 3000 per minute, but we need every second. That's why, that's a frequency, how many waves or vibration per second. That's why we have to divide by 60 to know how many waves are there in 1 second. Is it clear, this one? In question 36, which statement about electromagnetic induction is correct? What is electromagnetic induction? Electromagnetic induction state that change in the magnetic field induce EMF. And a conductor should cut the magnetic field. If it is parallel to magnetic field, like example, if I have a north and south, and I have a conductor which is parallel to the magnetic field, and I'm moving right and left, it won't produce induced EMF, because it is not cutting the magnetic field. It should be perpendicular to the magnetic field, or it should cut the magnetic field to induce EMF. So a conductor moving parallel to magnetic field, it never produce an induced EMF. It should always be perpendicular. How it should be? Like we have a north and south, and the conductor should be like this. So the direction of the conductor and the magnetic field, when they're perpendicular to each other, it can cut the magnetic field. There will be a change in magnetic field, which induces EMF. Then the second one, the direction of induced EMF always oppose the change in magnetic field. That is also known as the Lenz's law. Like always, whenever there's an induced EMF, it will always oppose the change in magnetic field. Example, you have a solenoid and you are moving the magnet towards north and south. So if you're moving the magnet towards the change in magnetic field, like in there will be a change in magnetic field, but the strength of a magnetic field is increasing. What this will try to do, it will always try to oppose the change. How it can oppose the change? By producing a pole, north side well, pole will be here and south pole will be here. And the direction of the current according to right hand grip rule in this manner. But when we move the magnet away, we have north and south, and we are moving the magnet away. So the magnetic field is changing. There is a change in magnetic field. So what this strive to do, it will try to oppose the change. And the magnetic field is decreasing. So this will try to increase by producing an opposite pole, and the direction of the current will also reverse. This is what happens when we are moving the magnet towards or away. The direction of induced current will always be opposite. So the direction of induced EMF always oppose the change in magnetic field. That's why B is the right answer. Why not C? The induced current is in a direction parallel to the motion. That's wrong. It is always perpendicular to the direction. Induced EMF decreases when the speed of a conductor. That is opposite. It will increase, not decrease. So this is wrong statement. So B is the right one. Is it clear, this one? On the moon, all objects fall at the same acceleration. So why the objects have the same acceleration? Because they experience the same gravity, or acceleration due to gravity is constant. Which statement explain this? On the moon, all objects have the same weight. It's impossible objects to have, all objects have same. Like example, on the moon, if I have 2 kilogram, I have 5 kilogram, I have 10 kilogram, they cannot have the same weights. They have different weights. So this statement is totally wrong, that objects cannot have the same weights. They will have a different weights. The moon has a smaller gravitational field strength than Earth. So the moon has a smaller gravitational field strength than on Earth. That is also correct. But the question is which statement explain why the object, like when we drop 10 kilogram, when we drop 2 kilogram, when we drop 5 kilogram, why all will hit the ground at the same time, or all will have the same acceleration. So we have the formula W equals mg. Weight is mass into gravity. Or weight divided by mass is equals to gravity. So whenever we take a ratio between weight and mass, we will always get a constant answer or constant acceleration. So weight of an object is direct. What does it mean? Weight and acceleration of mass are directly proportional. When weight and mass are directly proportional, the ratio will be constant. And if the ratio is constant, it means the gravity is constant. And gravity is constant means acceleration due to gravity will also be same. Like, for example, the gravity of the moon is 1.6. Just for explanation, if I say the gravity of the moon is 2. So if we say the gravity of the moon is 2 Newton per kilogram here. Here also 2 Newton per kilogram. What will be the formula if they were inversely proportional? When two quantities are inversely proportional, their product will be constant. Like weight into the mass, weight multiplied by the mass, weight multiplied by the mass should be equal to gravity if they were inversely proportional. When they're directly proportional, the ratio is constant. So idea is that when we divide the weight with the mass of an object, we always get a constant answer, and that constant answer is like a value of a gravity, or also known as acceleration due to gravity. Because when object accelerate without the gravity, without the air resistance, they always have the constant acceleration. Say on Earth, you're dropping, say we have 5 kilogram on Earth, and I'm taking gravity of Earth as 10. So this will be 50 Newton. We have 2 kilogram and its weight will be 20 Newton on Earth. We have say 3 kilogram, it will be 30 Newton. So what is a value for the gravity or acceleration due to gravity? So that is weight divided by mass. So 50 divided by 5. This will be 20 divided by 2. This will be 30 divided by 3. So that's equal to 10, 10, 10. So they all will have the same value of acceleration due to gravity, or the gravity will be constant. That's why statement C explain that when weight is divided by the gravity, when two quantities are directly proportional, the ratio is constant. So when weight is divided by the mass, not the gravity, we will always get a constant answer. And that constant answer shows the acceleration due to gravity. And if there was a air resistance, then weight divided by mass will not get a constant answer. Like the resultant force divided, not weight, the resultant force divided by mass will get a different answer. So we'll have a different acceleration. For falling object with air resistance, acceleration decrease, but without air resistance, the acceleration is always constant. So simply W equals mg, or W divided by m is equals to g. When two quantities are directly proportional, the ratio is constant. That's why C is the right answer. The diagram shows what is the magnitude of the resultant. How to work out the resultant force. This is a two perpendicular vectors. So to get the resultant, we just join 8 Newton is there. This will be 8 Newton, and we draw 6 Newton from the top by using a rectangular, like example here, we have 8 Newton horizontal, 6 Newton vertical. So what will the resultant? Resultant will be from tail of the first to the head of the last. That will be the resultant. So you can use your scale. Like example, just measure this length. There's also another way you can do by measurement, or you can also do by calculation, because the two vectors are perpendicular. So you can use the Pythagoras theorem, a right angle triangle it is forming. So it will be under root 8 square plus 66, 8 square plus 6 square. So 8 square is 64 and 6 square is 36 in a root. So when we add them, it will be equal to 100 in a root, and root of 100 is equals to 10. That's why C is the right answer. You can also use a triangle method. It will give you the same answer. You can use a triangle or a scale diagram. It will also give you the same answer. You will measure this length, like for 8 Newton, measure the length and then just use a ratio. For example, yeah, how it can be done with the ruler or the scale. What you will do, you will measure this line like 2 Newton. This is a scale. You place your ruler or the scale here. Place your scale here next to this 2 Newton and find how many centimeter it gives. Like example, 2 Newton is equals to 1 centimeter. Example, because I don't have the hard copy. So you have the hard copy. You just place your ruler or the scale. next to this 2 Newton, and you got the scale that 2 Newton is equals to, it can be 1 centimeter, it might be 2 centimeter, we don't know. Any value according to, say, 2 Newton is equals to 1.5 centimeter. Example. Then after drawing the resultant, how to draw resultant? This will be 6 Newton. So we get the resultant by drawing tail of the first to the head of the last, and then measure this length. Say example, say this is 6 centimeter, just an example, 6 centimeter. So this 6 centimeter will be equals to X Newton. Just cross multiply, you will get the answer. So using a ruler, you will first find what 2 Newton stands for. How many centimeters are 2 Newton? Then draw the, using a right angle, like use a triangle method, find the resultant and measure the length of a resultant and just convert into the final answer. Is it clear, this one? What is the purpose of a split ring or commutator? They reverse the direction of the current every half cycle so that the DC motor will rotate in one direction. Example, so we have a rectangular coil. And we have, say, these are the split ring X and the another one is Y. And we have side A, B, C, and D. Now, if there is a current, like a conventional current is there from this side, so side A, and this is a north pole, this one is a south pole. Which direction side AB will experience the force? So if you use a left hand rule, like example, index finger represent a magnetic field, second represent direction of the current. So thumb is pointing into. So this side will experience the force into, and this side will experience the force out. And now what happened? It will split, like it will change the position as it rotates. So when it rotates, the side CD will be on the right hand, on the left hand side now, and the side AB will be there on the right hand side. So this will be side CD, and this will be side BA, and we have north and south. And the position of split ring commutators also changes, like this is Y now, and this one is X. But the direction, conventional current is coming from left hand side. So what is the direction of the conventional current? Now from B to C, and then C to B, and then from B to A. And now the side C and D will experience a force into, according to Fleming's left hand rule, and the side AB will experience, or BA will experience, the force out. So what is the purpose of these split ring commutators? They reverses the direction of the current so that every time the left hand side, any side will come on the left, it will experience a force downward or into, and the side which is on the right hand side, any side which is on the right hand side, it will experience a force out. So as a result, it will continue to rotate in one direction. It won't reverse the direction. That is what happened in DC motor. So here we have option. What is the purpose of a split ring commutators? In a DC motor, ensure that the magnetic field of a motor changes. Magnetic field does not change, current changes. Current in direction of the current changes. After every half rotation, direction of, to ensure magnetic field of a motor stays the same in all time. So direction of a current reverses, and that reverses the direction of the force as well. You can see here, what is the direction of a current for the left hand side? It was from A to B, then B to C, and C to D. But what is the direction of a current here from D to C, C to B, and B to A. And the direction of the force is also reversed, because first the side AB was experiencing the force in, and side CD is experiencing the force out. And here the side CD is experiencing the force in, and BA is experiencing the force out. So direction of the current reverses, direction of the force reverse, but because on the left hand side, any side which is coming on the left, it is experiencing the force into, and any side which will be on the right hand side, it will experience the force out of. So relative direction does not change. Like any side which is on the left hand side will experience in, and any side experience on the right hand side experience the force outward. So to ensure that the turning effect of the motor changes direction every half rotation, no. To ensure that the turning effect of the motor remains same, because how turning effect of the motor remains same, you can see that left hand side always experience into force, and the right hand side always experience out, irrespective of which side is this. It can be AB, it can be CD, it does not matter. Always the left hand side in and right hand side out in this case, which cause a continuous rotation of this motor. Is it clear? The DC motor? That's why option D is the right answer. Four circuits are there, four diodes. In which circuit direction of the current is always from red to black? So first AC, you have to, for AC generator, you have to check both of them. Like example, this is positive, negative. So direction of the conventional current, direction of the direction of the conventional current from positive to negative. So it will flow. Then this will flow. So this is from red to black. But we have to check like when it will flow in this way. First this positive, negative. This is one way. Then because it's a AC, we have to check the other way around. So first this is positive. This will go here, but it will be, this will be blocked. So it will go from here and then. So what is the direction for this one when we change? It is also from red to black. So even positive or negative, any direction we take, it is from red to black. Why not B? First, if we take this positive, negative, which diode will allow? This diode will allow. Then it will go from black to red. So that's why B, we don't have to check the other way around. If one is not working, definitely the other won't work. Positive and negative. When it is here, this will allow. But now two possibilities. This diode can allow, the resistor can allow. But because the current can move, like follow the shortest path, so in this case, the current will move in this way. And the other way around, why it is not possible when you're taking positive and negative? See, the current is moving here. Then if you take red to black, but it cannot go out. It has to just make a loop. So that's why C is totally wrong. And what about D? Positive and negative, current will move from here, then here, then again it end in the same loop. So it is not going out from this direction, right? Black to red. If you take other way around, if you take other way around, so again, it does not make a sense. Like it should reach the negative terminal. It's from red to black. Is it clear why A is the right answer? Because when you take positive, this will be the path. If you take this positive, negative, because you have to check both as a AC supply. So again, it is from red to black. A student investigate 4 different radioactive isotopes. Student place a detector. The background counts are 36. So means the count rate is 150. So how many are the source? If the 36, so 36 are due to the source. So how many are due to the, 36 are due to background. So how many are there due to the source? So it will be 150 minus 36, 114 for 114. Then this out of 212, 36 are due to the background. So 212 minus 36, that will be 176. So 176. The table shows the detector reading at the start of and after 8 hours. Which isotope has a half-life? Okay. Sorry, I was reading in down or like here 150 become 36. So how we can work out 150 become 36? So if it is 150, how many are there due to the source? So it will be 114 are there due to the source, and 36 are due to the background. Now after half-life, only the source radiation will become half. So 114 divided by 2, so that is equals to 57. So after half-life, how many counts the detector should record? 57 plus 36, so it should record 93. But the detector is not recording 93, it is recording 36, so it cannot be. Because the question is, which isotope is having a half-life of 4 hours? So after 4 hours, this is after 8 hours. So after half-life or after 4 hours, this should be the count. And then after another 4 hours, so it will be 57 divided by 2. That is 28.5. So 28.5 plus 36. So the count rate will be 64.5. So after 8 hours, the count rate, if A was a right answer, after 8 hours, it should be 64.5, but it is not 64.5, so A is not. Now we check B. For B, we are receiving 212. And out of 212, 36 are due to the background. So how many are there due to the source? 212 minus 36, that is 176. Then after half-life, after 4 hours, so 176 divided by 2. How do we know that one half? No, we have to find like which isotope is having a half-life of 4 hours. So we are considering if this isotope was having a half-life of 4 hours, then what will be the counts after 8 hours? We are considering because we want to if do our calculation by considering if it was a half-life of 4 hours. So 176 divided by 2, that is 88. So after 4 hours, it will be 88. Then after another 4 hours, means after total 8 hours, so it will be 44 plus 36. So 44 plus 36, that is equals to 80. So we should get 80, but we are not getting 80, we are getting 53. So it cannot be B. Then we check C. If we have 260 counts and out of 260, 36 are due to background. So how many are there due to the source? 224. Then after half-life, 112 after 4 hours. Then after 8 hours, another 4 hours, it will be again divided by 2. So 56. So 56 plus 36, what it will make? It will make 92. So means C is having a half-life of 4 hours, because after 8 hours, it will give us, if it was having a half-life of 4 hours, so after 8 hours, it will give us a count of 92. Is it clear, this one? So we consider how to solve this question. We consider each of them is having a half-life of 4 hours. So we identify how many radiations will be there after 8 hours for each of them, including a background. The diagram shows a conducting metal. In which direction should a rod be moved to induce a current in the direction of an arrow? So induced current, you will use a right hand rule. So index finger, we want to produce a current in from P to Q. Your first finger represent the magnetic field, which is from north to south. So your index finger should point in this manner. And use your right hand rule. Index finger is pointing it towards the south. Your second, so index finger, first finger is pointing towards south. Your second finger point in the direction of a current. So the direction of a current is from P to Q. So your second finger should point in this manner. So if your first finger is pointing towards the south and your second finger is pointing in this manner of the right hand, where your thumb is pointing, that shows the direction of the motion of the wire. Why right hand? Because we are finding an induced current. For induced current, the change in the magnetic field, right hand. If the question was what is the force due to the current, well, like there is a current passing and we want to calculate the force on the wire which is placed in a magnetic field, we'll use a left hand. But this is for induced current, we use a right hand. Is it clear? So index finger is pointing toward, right hand index finger pointing towards south. Second finger represent the direction of a current, induced current from P to Q. And your thumb is pointing in the direction of the force, which is like direction of the motion of the wire. Is it clear, this one? So remember one thing, if we have a supply and there is a current from the supply, we want the force, we use a left hand. But if there is an induced current due to a change in magnetic field, we'll use the Fleming's right hand.